Hey, how's it going? My name is Reno, and today I'm going to be building a tensegrity model and describing its relation to posture and movement within the body. So here I'm starting with 3 elastics and 3 pencils, and these pencils are going to represent the bones of the body, and the elastics will represent the soft tissue. The pencils will also represent the frontal plane, which I'll show here in a second. Represent the frontal plane and sagittal axis, the sagittal plane and frontal axis, and lastly the transverse plane and vertical axis of the body. In addition to the pencils representing the bones and respective planes and axes, they also represent the isolated compression of the body, while the elastics are going to represent the soft tissue, which is the joints, muscle, and fascia, as the continuous tension of the body. The common misconception is that our bodies are more like a continuous compression unit, with how the bones are just stacked, like a stack of bricks or a building on top of the ground. But what this model is going to show is that we're actually a tension and compression unit. The way our bodies are made up, similar to the unit, allows for various movement like twisting, bending, etc. If we didn't have continuous tension across the isolated compressions in different segments of our bodies, the bones would simply fall to a pile on the ground. As I put together the first 2 pencils, you can already start to see that there isn't an equal distribution of compression and tension forces across the unit. We can use this example to represent the idea that sometimes, due to bad postural habits or maybe even faults in our physical training, it can lead to weakening of muscles and joints in certain areas, or more or less tension due to muscle imbalances on one side or another pulling the bones out of alignment. I'm fast forwarding here a little bit because I did struggle with putting the structure together using pencils. Now, as I near the end of the building process of the structure, you can see again how the imbalances and tension around the areas of compression can lead to a lack of strength or stability. And if load is applied to these areas of weakness or unevenness, such as me just pressing the structure lightly, it can easily result in injury or strain by twisting the bones and soft tissue too far or too hard, by pressing too hard. But now as I get the elastics adjusted properly, you can see how the tension becomes much more evenly distributed across the pencils, and therefore the integrity of the structure comes together to increase its overall strength and stability. Now applying load to the structure or some kind of movement, it can actually get stronger, and theoretically the even distribution of forces or loads can generate or support optimal movement and performance. Now, speaking of movement and performance, that leads into the next part of the video where I'll be demonstrating some movements through the previously mentioned planes and axes. So the first exercise is the lying hamstring curl, which represents knee flexion on the way up and knee extension on the way down. And then in the second exercise is the leg extension, which is going to be a knee extension on the way up, knee flexion on the way down. Both of these movements happen in the sagittal plane and frontal axis. Next is a basic seated row to demonstrate retraction and protraction of the scapulas, retraction as I pull back, and protraction as I let the handle and my scapulas go forward. This movement occurs in the transverse plane and vertical axis. Here is a seated abduction exercise which rotates my hips laterally. And the second is a seated adduction exercise which rotates my hips medially. Both movements occur in the transverse plane and vertical axes as well. And here is a basic dumbbell lateral raise exercise to show abduction and adduction of the shoulder joint, abduction on the way up and adduction on the way down. These movements occur in the frontal plane and sagittal axis. Lastly, one final movement that occurs in the frontal plane and sagittal axis is an abdominal exercise that displays lateral flexion of the lumbar spine.